I am Assistant Professor Kute Akshada from SND Engineering and Research Center, Evla. Welcome to online lecture series. In last lecture, we have seen infrared spectroscopy, and in this lecture, we have seen types of vibrations. Two types of vibrations are stretching and bending. In stretching, subtype is asymmetric and symmetric, and in bending, subtype is scissoring, rocking, wagging and twisting. First is, there are two modes of molecular vibrations, stretching and bending. In polyatomic molecules, each atom is having 3 degrees of freedom in 3 directions, x, y, z axis, necessary for describing its position relative to other atoms in the molecule. A molecule of n atoms has therefore 3n degrees of freedom. For non-linear molecules, 3 degrees of freedom describe rotation and 3 describe translation. The remaining 3 and 6 degrees of freedom correspond to vibrational degrees of freedom. Factors influencing absorption. Symmetry. Symmetric compounds do not possess dipole moment and are IR inactive. Example, symmetric acetylene. Next, coupling. There are so many factors which causes couple vibration in IR, and it will influence the intensity and there are so many factors which causes couple vibrations in IR, and it will influence the intensity and shape of the absorption bands. Example, normally the band due to CC bond is around at 1650 cm inverse, but due to mechanical coupling of two carbon-carbon systems in aniline give two bands at 1960 and 1970 cm inverse. Fermi resonance. Fermi resonance results in an unexpected shift in energy and intensity of the bands. The number of fundamental vibrations. A molecule containing n atoms has 3n degrees of freedom, 3 of which are assigned to translational, another 3 of rotational, and remaining 3 and 6 to vibrational motions. First, stretching vibrations. In this mode of vibration, the atom moves along the bond axis to the bond length, increases or decreases periodically. This type of vibration corresponds to one-dimensional motion. Bending vibrations. In this mode, change occurs in bond angles between bonds with a common atom or movement of group of atoms with respect to remainder of a molecule without movement of the atoms in the groups. Fermi resonance. Fermi resonance results in an unexpected shift in energy and intensity of the bands. Hydrogen bonding. It can change the shape and position of IR bands. Stronger the H bonding, greater the absorption shift. Intermolecular Bohr bands and intramolecular Sharp bands. Next, electronic effect. Electronic effects such as inductive, mesomeric and field effect may cause shift in absorption bands due to the change in absorption frequency. Bond angles. Difference in bond angles can also lead to the changes in absorption bands. Sampling. Samples of the same substance shows shift in absorption bands as we pass from solid to gaseous, and hence the samples of different phases have to be treated differently in IR spectroscopy. Sampling of solids. Solids run in solution, mull technique, press pellet technique, solid films. Solid run in solution. Dissolve solid sample in non-aqueous solvent and place a drop of this solution in alkali metal disc and allow to evaporate, leaving a thin film which is then mounted on a spectrometer. Example of solvents: acetone, cyclohexane, chloroform, carbon tetrachloride. Second, mull technique. Finally, powder sample plus mulling agent and make a thick paste. Transfer the mull to the mull plates and the plates are squeezed together to adjust the thickness. It is then mounted in spectrometer. Third, press pellet technique. Finally, powder sample is mixed with about 100 times its weight of kBr in a vibrating ball mill, and the mixture is then pressed under very high pressure in an evacuable die to form a small pellet. Advantages: it eliminates bands which appear due to mulling agent. Pellets can be stored for longer period of time. Concentration of sample can be adjusted. Disadvantages: not suitable for polymers which are difficult to bind with KBr. High pressure may change the crystallinity of the sample. Fourth, solid films. Here amorphous solid is dissolved in volatile solvents and this solution is poured on a rock. Salt plate, then the solvent is evaporated by gentle heating. Sampling of liquids. Liquid sample can be sandwiched between the alkali halide plates. The sample cell thickness is 0.01 to 0.05 nanometer. Sampling of gases. Here gases sample is introduced into a glass cell made up of NaCl. Very few organic compounds can be examined as a gases. Example 1,4-dioxane. Sampling of solutions. Here 1 to 5% of solution is placed in solution cell made up of metal halides and the second cell containing the pure solvent act as a reference. Important solvents used are chloroform, CCl4, carbon disulfide, etc. Thank you.